So hello students, welcome to the second week of the next generation sequence analysis class. This week we're really going to start to get into some of the tools that you'll be using really for the rest of your careers, and um, we'll really get into some of the quick data analysis methods that you'll be able to use by learning how to work the Unix command line. So I did put in, along with discussion with Gabi, the coordinator for the bioinformatics program. Me and him several years ago decided that it really was essential now to be able to work the Unix command line, simply because so many tools are being developed, on a Unix platform, and it just makes sense to for students to begin to learn how to execute those programs and to become proficient at working with file management, the remote login benefits, the remote hosting and interaction benefits that the Unix systems have. It's not that Windows doesn't have some of these benefits, but it's just that the user base, in the next generation sequence analysis community is heavily sort of centered around Unix. So today's lecture, I'll be basically sticking to kind of what I call the practical essentials of Unix for bioinformatics. So, this is a big topic, and depending on your level of expertise, some of you may be quite advanced. I don't know your backgrounds. If you have a computer science background, working a command line is almost synonymous with working a computer. But if you're not from a computer science background, then you have an opportunity here today and doing the homework to really just kind of get into some basic analysis. So we'll be kind of targeting the entry level, so hopefully you can follow along, and if you're a little bit more experienced, maybe this will just be a refresher for you. Again, I'll be highlighting some practical things. These are things that commands and methods that I'm using on a daily basis as I'm analyzing next generation sequence data. We'll be working mostly with the born again shell. That's mostly because while there's other alternatives, Macintosh, OS 10 uses born again, and more advanced Macs use use Bash. As do the most common distros of the Linux or Unix-like platforms. So Bash has become very common. Now I will point out that there's different versions of Bash on different systems. So it's possible, and since I work mostly on Ubuntu, which is a Linux distro, I know the commands on Unix, on the Ubuntu version of Unix, but I am not as familiar with Macintosh. So if you have a Mac, don't be surprised if some of the commands we talk about are actually not, they throw an error when you issue the command, because, for example, here's one I know about, MD5 sum, which I'll tell you about, versus MD5 on a Mac, MD5 sum on Ubuntu, MD5 on a Mac. Related, but simply not the same commands. So today we'll just be covering some very simple topics, and really I'm not going to dedicate as much time to lecture as I did in the first weeks. That's because some of this material is not as well sort of suited to lecture style or presentations. I think that the best way to learn the command line and to learn how to use some of the Unix tools is to actually sit down at the command line yourself, work through some tutorials. So I've made a number of those available. The most important one is one that I'm asking you to complete for as part of your homework assignment from the Corf Lab. It's a Unix tutorial that's really targeted at entry-level bioinformatics, and I want you to work through that. I have a couple of questions in the homework that will kind of check to see how far you got, or if you picked up on a couple of the issues that I wanted you to pick up on, and then you'll be able to apply some of those in a fairly simple homework exercise. Um, so anyway, some of the topics that we'll be talking about in the next 40 or hopefully 40 or so minutes. I don't know how long this will take, but hopefully not more than that. Basic system administration, file management, working with text. This is huge, and it's a huge benefit of Unix-like systems, because there are a lot of binaries or commands that you can use to extract information from very large text files. I mean, just as an example, one of the files I'm working with right now is 125 gigabytes. This is a file that has 20 complete whole genomes, including the BAM files for those, very large, what we call merged BAM. So what are you going to do with 125 gigs? That's more than, some of your older computers even have, on your hard drive. And you can't open that file like you might if you're used to a Windows-based sort of text editor where you simply double-click on the file, you open it, your computer will crash. Okay, we'll be talking about I/O streams, input-output, importantly concepts of standard in, standard out, standard error, piping, and redirection. These are some of these piping commands that you'll see give Unix a huge ability to customize analyses by stringing together series of commands. We'll be talking about that. We'll talk briefly about the shell environment, including how to write some simple shell script. So many of the pipelines that you hear about, where people have built pipelines for, say, de novo assembly or SNP calling pipelines or RNA-seq analysis pipeline, are written in different languages. Sometimes shell scripts. I actually prefer shell scripts for my own pipelines that I develop, and I'll just be introducing you to some of the basics. And then we'll just quickly talk about working with remote hosts. Some of that we've already done using SCP to download some of the homework files. So just quickly, this is review. Most of you will know this, but if you don't, the anatomy of a Unix command. This is a command called ls, which simply lists the name of the files. The -al customizes the command to give some desired output. So if you just type ls, you'll get a list of files. If you type ls -al, you'll end up with a list of files plus hidden files. That's what the A gives you, and the L gives you a list with file permissions that I'll show you. And then this is the target directory. If you don't put anything here, it'll default to the current working directory. Okay, so this is an argument, and this is the command, the options, and any arguments. So I mentioned it already, but this is really a binary. It's a compiled program that exists on your machine, and I'll show you where in a moment. But when I say binary or program, I'm oftentimes referring to the same thing. It just means that it's compiled. You can type it, and this program does one thing very well, and that is list the files in a directory. So if you want to know the sort of what the options are, how do you know what these options are? How do you learn them? Well, a lot of people, to be honest, I think go to Google and start Googling around. But sort of another way to do that, and here I'm going to try to do a little bit of a interactive here. So can you guys see this? I wonder if I shouldn't blow this up. Let's see if I can just blow up my terminal. Let's see. Nope, that just reset the size of the window. Give me 1 second. Let's zoom in. How about that? There we go. Maybe you can see that a little bit better now. Let's zoom in again and see if we can really blow this thing up. So you can see if it's you're watching on a small screen. Okay, there we go. So now hopefully you can read that. We're in a directory called week 2 here that I've made. Let's do a man on ls just really quick just to show you that. So here's the instructions, right? So here's, you can say A, that -A, that means do not ignore entries starting with dot. Those are hidden files. I'll tell you about that in a second. Okay. So getting started with the Unix command line, let's go back to where we were here, and let's just run through some of these pretty quick. These are things that, sometimes you just orient. When I first sit down at the terminal, sometimes I'm just like a little tired in the morning. Who am I? Well, I'm Jonathan. That's my username. Um, what shell am I using? Okay, I'll echo. That's kind of more or less like print. Here, this shell is a variable. We'll talk about that. So what shell am I using? I'm using bin bash. Bin means binary. Bash is the program. So bash is actually a compiled interpreter. So it allows you to, it's interpreting the commands that you issue. We can check the version of bash that we're using. Sometimes versions, as I mentioned, will differ from computer to computer, and so the commands will frequently differ, or their behavior maybe slightly. We can check our present working directory, okay, which is root home, Jonathan, week 2. Just going to keep hitting clear here so I can stay up high. We can check my home directory. Okay, so this is again a variable called home, and the $sign means get the contents of that variable. So we're printing the contents of home Jonathan. So we can use which on really any program, which echo, bin echo. You can do that on the SAM tools installation you just did. Here we just did man ls a second ago, and then here we can check the date and time. Here it's Monday, September 9th at 6 o'clock or almost 7 o'clock. Redskins football game's coming on, so I've got to finish here fairly quickly. So just to point out, throughout I'll be talking about commands. You can recognize a command here. I'm just putting a % in front of the command. Pretty much throughout all my tutorials and everything, that's kind of the syntax I'll use. That just means this is the command prompt. And then we can type, what did we just do in the last 10 commands or so. Let's do tail -8, because maybe we didn't do all of them. There's the last 8 commands. Okay, now here I just used a pipe here, and we'll talk about that. If you type history, you're going to get a long thing here that it's the history going all the way back, since the dawn of time. When I've been working on this computer. Actually, I think it just stores like maybe 3,000 or something commands before it clears the buffer. Okay, so there you go. Hopefully you learned a couple of commands there. Sometimes this is just it's quick hitting lecture trying to give you exposure to what I think are a lot of useful commands. Okay, so here we have file management. So it's really important to understand your system. Okay, Unix and Mac systems all have a very similar directory structure, and they have this principle called root. Root is the very topmost directory. So just go to root here really quick. So we can just do a cd and go to root, just /. We're now at the very topmost tier here of my directory hierarchy. So if we do an ls here, you can see bin, boot, etc. These are all directories. I think these are actually symlinks, but don't worry about that. We won't talk about symlinks in this class. Okay, so the important concept is that root, there is a top directory that contains all subdirectories on your system. Some people call these folders. That's still okay to do. I'll usually refer to them as directories and subdirectories. So there's a few essential commands here I want you to know when we're talking, with respect to file management. PWD, we already went through that. That's the present working directory. You can see here that I am at root. I can cd to my home like this. Okay, so squiggly, that's just universal symbol for home. Now we can do PWD again, or root home, Jonathan. Okay, so you can see up here in the root directory that there's a directory called home. Okay, and that home directory is now where I am. I'm in a subdirectory called Jonathan inside of home. So obviously, there's a lot of commands here that you could learn. Let's cd into the week 2 directory. This is where I've set up a few files that I'll just use here quickly. We can make dir. We can make a directory called temp. Okay, now we can ls. We can now see that temp has appeared in blue on my system. We can remove that directory. When we remove a directory, we have to include the recursive -r. If that was just a file, we could make a file here called temp. Touch just makes an empty file. Now temp, you can see here, is in white. We can just remove temp without -r. Some of these files get to be a little bit big, so let's go into FastQs. Now I've really stripped this FastQs that are in this directory way down, but we can check the human readable disk usage. So du-h is a really nice command because it spits out the disk usage in terms of something you can read, which in this case is 433 megs. Okay. Then let's go up a couple directories here and say, you know, I'm in my home and I have a lot of FASTA files. This find command is really powerful command. Okay, I'm only showing you maybe the most simple usage here, but it recursively looks down through all the directories beneath it, and you know, we can use a wildcard here for all files that end in FA. So wildcard here means match anything before FA. FA is at the end of the command. Find, we're looking in dot, which is the present working directory. Okay, that's where we are, is at dot. So it says this means find inside of dot any file with the name that matches this query. And it's going to do this recursively, so it's going to look down through all of the directories in this our present directory. So we can do that here, and you can see that I have, you know, a number of FASTA files, you know, spread across, you know, a couple in my desktop, my precision directory, my references directories, anyway, a lot of FASTA files. So find is a very powerful command. You could read the man page or do some Googling around. You can delete files that are, you know, not in the present directory, you know, recursively very easily just by adding the -delete flag at the end of after calling names, so you can string together many options. It's a very useful command for more sophisticated users. This command, you know, if you haven't gotten to use familiar with it, I highly recommend it. So what we're going to do is go back into week 2 here, and let's go into one of these FASTAs. Oh, one thing here that's useful is the autofill. Notice I've typed FAS. Okay, there's actually two file types with FAS. There's FASTAs and FASTQs. So if I type tab, which I just did, it filled into T because that's the last thing that's in common between these. Let's do a different example. Let's say I type SC. Scripts. I can use tab autofill to fill in the name. That ends up saving you a lot of time when you're working the command line. Okay, so here if we just type T and then we hit tab, it fills in for us tables. Okay, very nice feature. So let's go into the FASTAs and look around there, and let's do a gunzip on this particular FASTA file. What gunzip does is notice that it stripped the GZ, but this is a compressed file. It's a gzipped file. Now gzip by default removes the .gz and it uncompresses the file. Okay, so now we have an uncompressed FASTA file here. We can then zip that file right back up. So gzipping is used for file compression. This is a decent sized file, so this will take a second. Okay, we're back to our gzipped file. So to form a file compression that you use on individual files, not to be confused with tarring, which is when you are compressing or bundling really sets of files. So why don't we do tar? I have that on the list of essential commands here. Let's go over to the directory called small files, and what we can do here is create a tarball, czvf. C means create, Z means we're going to gzip it. Okay, V and F are things you don't need to worry about. I think it's verbose and force. But what we can do is we type that, then we type the name of the tarball we want to let's call it small.tar.gz, and the names of the files, we can use wildcard here as well. So here's star text. It just zipped the files up. It actually leaves the files here by default. You can add an option to this command if you'd like that will remove the files, the original files, if you'd like. We can check the what's inside the small.tarball by using the T option, tzvf. So here now we can see what's inside. Okay, so a.text, b.text, c.text. So that's useful. So you don't have to uncompress if you'd like to just visualize. So now we can, let's remove all the text files here, and now we can untar using xzvf. Just memorize these options, because if you just memorize this, you're gonna you'll use this command for the rest of your career. Okay, so now we're kind of back to where we are, where we can remove the gz file there, and let's introduce the concept of dots. Okay, so dot, I told you, was the present working directory. So if you do cd dot, nothing changed, right? If we do cd dot, nothing changes, because dot is cd to the present directory, so it's not doing anything. But cd dot dot, okay, does do something. Okay, that is the directory above. Okay, so here we've just navigated from small files go back down to small files. Okay, and then we can go dot dot back up into our week 2 directory. Okay, so the dots are important for file navigation. There's one other thing I wanted to point out here, and that's relative versus absolute paths. Okay, so if you preface the path with a / that means you are implicitly saying that with respect to the root directory. So here's where you're going to have to specify the entire path to my home if that's where we want to go. Okay, as opposed to, let's go back down here into week 2, as opposed to just typing cd small files. Notice here I am not prepending with the full absolute, what we call absolute path. This is a relative path. It's relative to where I am. Go to the small files directory, not relative to root. Okay, so, or the root directory. Okay, so if we wanted to do that same thing from root, we could go cd home Jonathan small, well, we'd have to go to week 2, and then small.files. This is the absolute path to small.files, whereas a moment ago I just used the relative path. Okay, so there we go. Here we'll go relative here with the dots. Finally, hidden files. So we're back in my home. There are some important hidden files. Using the ls-al command, we can see those. Here's one called .thumbnails. Here's one called .ssh. There's also a couple up here that are important, like profiles should be in here somewhere. There it is, .profile. We'll talk about that in a second. These are hidden files, so if you just type ls, you won't see them. Right? So if we just type ls and you look for profile, it's not here. Okay, profile is not there because it's hidden. It has a dot in front of it. Okay, let's advance to system directories and organization. Briefly, where are the binaries programs stored for your system? Usually in root bin or root user bin. Root user local, so root here meaning again the very top directory. User local, this is where oftentimes you'll install your third-party software. So I'm telling you this because for me I always want to kind of be very organized. And knowing where to put these programs is part of being a good bioinformatician. And so I want you guys to kind of, when you're installing software or your third-party tools, use user local. User bin and bin, these are mostly reserved for things that are compiled, by the system, at the time when you installed your your platform, your operating system. Where should you put your scripts? Well, the recommended place usually is in home bin. Okay. How does the shell know where to look for a program? Well, this is just an important concept that you need to understand. When you do ls, okay, the program knows to look for bin ls, or it's looking for ls, but how does it know that it's in bin ls, okay, the root bin directory? Well, it knows because there's a specific variable called the path, okay, which contains a series of directories that the shell starts to look in for certain binaries. So it starts at root home Jonathan bin. It then goes to user local sbin, user local bin, user sbin, etc. Okay, and actually you can run into clashes, so you have to be careful. If you have a single binary installed multiple times, it would run the one that was highest in the hierarchy here. Okay, so this is your search path. Your computer has to know where to find these binaries, and this is how it does it using the search path. So we can add a directory to search path. So if we go back into our week 2 directory here, and let's say that we want to add what's called scripts to our search path, okay, we can do that simply by modifying that search path and adding the full path or the absolute path to the scripts directory. Let's skip exactly doing that for now. I'll leave that to you if you want to at the moment. Maybe we'll come back to that. File permissions. So this is just really quick. When you do ls-al, okay, well actually just lsl, you'll see this. Here, are your. Why don't you do this if you're following along on your computer? Go to a directory and just type ls-l. You won't see the hidden files there, but you should see these permissions. Okay, so there's 10 columns here. The very first column tells you if it's a directory or not, basically, or it could be a link and be an L. That's also possible. But a dash means it's not a directory. It means it's a regular file. A D here means that is a directory. This is kind of hard to see, so maybe I should open the terminal again. If we just do ls-l, notice here we can see that where we're working in today's week 2 directory, all of these are directories. I don't have any files here. I guess we can make one. And now you can see here this new file a.txt just has a dash here. That means it's a regular text file. And then there are the permissions columns, right? So the first 3 columns are for the user. This is maybe not a good example because I'm both the user and the group. Okay, so I can type who am I? I'm Jonathan, and then groups. Here are my groups, but I'm also have a group called Jonathan. You could do this on your system and see how this plays out, but the second, third, and fourth column are the permissions for that file for the user. Okay, so I have read, write, and execute permissions for the fastest directory. By default, I only have read and write for the a.txt. This is set by what's called your umask. You don't need to worry about that for this class, but if you can modify what the default is here by modifying your umask. The next columns, let's see, 5 through 7 are for the group. The 8 through 10 are for other users that are on, sort of have an account on a particular system, but are not members of the group or are not the users themselves. So we can change let's add executable status just to that file I just made here really quick. So we can just do change mod a.txt here, So now let's see what happened. That a.text file a second ago just had a dash here at the executable permissions. So if we do an ls-l here, now we can see that the a.text here turned green on my my terminal here. That's how I have it set up. If you have Ubuntu, that's the default. But here, anyway, it changed from being a dash to being an X here because I added the mode sort of the file. Okay, so that it is now I have executable status for the group. Excuse me, for the user. Okay, this is a very detailed topic. If you ever get into system administration, this is the kind of thing that people do a lot, and there's a lot of options here and a lot of tricks to modifying these. So this is only the very most basic. So here's a couple of things I want you to know, and that is, when we're working with a lot of text, these are old hieroglyphics here. How do we go from all that text to, again, the nicely polished, analyzed genome? Well, one of the things we have to do in the meantime is learn how to handle these massive files like this 120-some gig file that I'm working with at the moment at my job. So let's quickly go, and I'm not going to have time to do everything here with you. I'm trying to not bore you to death with some of these commands, but let's if we have a really large file, let's go back up to these fast queues that have these are fairly moderately large files, although I have some on this computer that are much larger, obviously. But how would I begin to access these really big files? Well, to be honest, we'll skip right here to the end. Using zcat, this way you don't have to unzip the file. So these are gzipped files. You don't have to unzip it to start to view it. So zcat would be a way to take a peek at the file. So let's do that. Now I haven't showed you how to pipe yet, but I don't want what's going to happen is this is going to get flushed to what's called standard out, and it's going to start filling up my terminal with random text. So what I'm going to do here is just pipe to less, and here you can see now we can go down through sort of line by line, and this is the FASTQ format that I introduced in one of the lectures in the first class. Okay. Here's the name of the read, here's the DNA sequence, these are 50 base pair reads, here's a plus, and here's the base qualities.